The Indian Association of Structural Engineers, also known as CSIR-CRRI, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. CSIR-CRRI is registered under the Societies Registration Act 21 of 1860. CSIR-CRRI is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural engineering fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, CSIR-CRRI has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Kumar Ghosh, late Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Manoj Mittal, Professor R. Pradeep Kumar, and Shri Alok Bhaumik as its president. CSIR-CRRI is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, CSIR-CRRI has collaboration with various international professional like-minded associations and institutions like CSIR-CRRI, UK and FIB for strengthening global connections and professional exchange. CSIR-CRRI's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. CSIR-CRRI endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. CSIR-CRRI is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. CSIR-CRRI's activities are widely appreciated and known for quality technical contents. CSIR-CRRI is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, monthly newsletter, and Crossfall, a unique quarterly newsletter that confidentially reports structural failures and the lessons learned from them. CSIR-CRRI's publications are becoming popular with time. CSIR-CRRI has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, CSIR-CRRI started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. Reaffirming its commitment to professional excellence, CSIR-CRRI launched the accreditation program in 2023. This flagship initiative empowers practicing engineers to evaluate their competencies, identify growth opportunities, and strengthen the foundation for sustained professional success. CSIR-CRRI is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide hand-holding to the budding engineers. Joining CSIR-CRRI offers exclusive resources, mentorship, and networking with industry leaders. Members enjoy discounted registration for workshops, seminars, and events, along with discounted membership of FIB, opportunities for certification, career guidance, leadership roles, and enhanced professional recognition. IIA-STRUCT-E has its student chapters in several leading engineering institutions as well. Membership of IIA-STRUCT-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IIA-STRUCT-E is available on its website www.iastruct-e.co.in.
Vikas?
Yeah, sir, please start.
Dear friends, welcome to this webinar. The topic is inspection, assessment, and health monitoring of structures through instrumentation. Speaker is Engineer G.K. Sahu. His brief CV, he graduated from Government Engineering College, Bilaspur in 1987. And thereafter he obtained his master's in civil engineering from MNREC, NIT, Allahabad in 1989. He started his professional career as a scientist in the Bridge Engineering Division in CSIR Structural Engineering Research Center, Ghaziabad in 1990 and continued for over 12 years till 2002. Saul was engaged in the performance monitoring of structures through instrumentation and instrumented several highway bridges such as Balanced Cantilever Bridge at Varanasi, Simply Supported Box Gutter Bridge at Loknayak Setu, New Delhi, and several more bridges, and core number of nuclear power structures, and then the proof load test at Zori Bridge, Goa for external pre-stressing. Engineer Saul was transferred to Bridge Engineering and Structural Engineering Division CSIR-CRRI in 2002 and has been involved in structural health monitoring of several bridges, condition assessment, and remedial measures of many bridges, load tests of bridges, quality assurance, and quality control. He visited the United States of America and Myanmar for training in the condition assessment of bridges. He was involved in the evaluation of increased axial load effects for more than 10 bridges of railway. He has successfully managed condition assessment of over 2,000 bridges and was also involved in the structural safety audit of over 100 kilometer elevated 6-lane expressway. He also was on deputation to National Highway Authority of India as General Manager on upgradation of national highways for 2-lane to 4 to 6 lane in Northeast for over 5 years during 2008 to 2013. Indian South is a very active member of several professional bodies like Indian Road Congress, Indian Society of Wind Engineers, Indian Concrete Institute, the Modern Science Congress Association. He is a member of IRC and BS committees, the Bearings and Expansion Giants, and a member of several BS committees. Now, coming to brief about the topic, As we know, a large number of major bridges, ROBs, flyovers are being constructed as a part of infrastructure development in our country. These structures serve as vital link in the road and rail network. Upkeeping of these bridges for its intending service life poses great challenge for highway and railway engineers. For the long-term performance monitoring of bridges, various performance parameters such as strains, temperature, deflection, pre-stressing force, lateral pressure, corrosion, acceleration, forces on cables, settlement and tilt at the slab has to be monitored through bridge health monitoring system. Rigorous installation of various sensors and instruments at several critical locations on different components of the structure during construction and post-construction stage. The changes involved of the performance since indication of some sort of distress in the structure. Thus, instrumentation in the monitoring the design parameters and in the assessment of current health of structure to adopt the proper remedial measures at an appropriate stage. Now I shall request Engineer Sahu to continue further proceedings on the above topic. Engineer Sahu, please continue.
Thanks, Dr. Dhawan, and thanks to Indian Association of Structural Engineers for giving me an opportunity for just sharing my experience. This presentation is really contribution from thousands of engineers and technocrats. This is not mine only. It is really a very big contribution from all over the India. My seniors, my juniors, my colleagues, and all the professionals involved during my 35 years of journey. So this is capsule for 35 years. For all the engineers, I request kindly go through this one after my lecture also, and let us follow this practice so that we can enhance the service life of these structures. Let me share my presentation, sir. Are you able to see my presentation, please?
Yes, please.
Yes, sir.
Okay. Let us check whether it is moving or not. Is it moving, sir?
Yes, yes, sir.
Yes.
Okay, then we can start. Good evening, friends. I welcome all of you in this webinar. Actually, you see, for any structures, before recommending anything, first of all, I request all of you, you should visit once at least for 1 hour. Then only kindly recommend anything, because by having some photographs or something, you will not give proper perception of the bridge. As collapsed bridge is concerned, if you see the last 40 years data, the average life of collapsed bridge in India is 34.5 years. And if you see the global scenario, it is 52 years. So we should all have a very good effort to contribute to enhance the service life of these structures. So I request all the engineers, all the consultants, all the designers, all the concessionaire, contractors, supervision consultants, kindly contribute a lot so that we can enhance our average life of collapsed sector from 34.5 to at least 41st. Then let us have a global scenario 50 plus. So in that context, if you see, if you follow this presentation of 1 hour, I think we will definitely ensure our government, we can definitely get part with global, that is more than 50 years of average life of collapsed bridges. I'm going to cover introduction, inspection of bridges, distress mapping, condition assessment, then recommendations for remedial measures. If you see, our is the second largest road network. India is having second number, and bridges are the vital links. You see, national highway is having 1.46 lakhs kilometer. Now it is around 1.5, you can say, and it is only about 2% of the total road network. And then if you state highway, that is around 1.8 lakhs kilometer, and it is 3% only. And other roads, 63.4 lakhs, that is 95%. So if you see, national highway, it is having around 1.7 lakh structures. Railways is having 1.58 lakhs structures. So if you consider for the whole India, you can have around 75 lakhs bridges in India. So it is really very huge responsibility for the civil engineers to maintain this infrastructure of 75 lakhs bridges. So you can see this is one of the collapse case. And if you visit the bridge, really you can see what is happening. In 30 years, 40 years, 50 years life of the structures, no one is visiting. In major bridges, in 50% bridges, you will find no one has visited for last 20 years, last 25 years, last 30 years. That is the case. Only going through top of the structure will not give any contribution towards bridge. You have to see from the bottom only. If you see, this condition cannot pursue within 2 years, 3 years. If we are not visiting for 10 years, 15 years, then this will come. So we can avoid any collapse by visiting and providing some rehabilitation measures at the proper time. If you see this type of bridge, it is really within 22 years, this bridge has been declared non-serviceable. Because you see, the cracks are so widened in centimeters, not in 0.35 or 0.25, 0.5, in centimeters, and it is going up to the next level at the age of 22 years only. So the inspection is very much essential for our structures. I really request all the engineers, whatever they are having in their charge, let us visit at least once for a year. You can see this one. In all the flyovers, we are getting in throughout the India, shear punching of deck slab. And it can be avoided if you can inspect properly. Say this is the box girder case, or even for the simple deck slab, we are having shear punching problem in all the cities. The thing is that we are not seeing the structure at the beginning unless we are having this type of very big potholes first, then this type of shear punching of the area. If you go through IRCSP 18, there it is clearly indicated routine inspection at an interval of 1 year, detailed inspection at an interval of 3 years, special inspection after earthquake, flood, landslide, any climatic major changes. Then underwater inspection is also essential. If you see, there is provision in IRCSP 18, there should be bridge register. But if you visit in all India basis, you will not find 5% bridge registers. 90%, 95% is not having any record. And the records, whatever we are having, that is not giving the details what we intended, original bridge register and inspection report. The original bridge registers, we should have all the original data. What is the soil details? What is the foundation, drawings, structure, substructure, bearings details, superstructure, corrective works, if anything get modified in between. All those things should be there in the original bridge register reports. Then that inspection, whenever you are visiting, there should be some remarks for that particular bridge. But this thing is missing in all the sites, I can say, because only within 5% you will get, 95% you will not get. You have to inspect all these components during inspection. That is superstructure, bearing surface, deck slab, whatever the supporting T-girders, I-girder, box girder, footpath, substructure, bearings, pedestal, bearings, abutment foundation, pier foundation, wing wall, retaining wall, dirt wall, non-structural element also. Approach slab, parapet, railing, crash barrier, expansion joint, protective walls, waterways also. You will find in 70% cases, waterway is not clear. Drainage spout, in 95%, drainage spout is not working. Bridge number in 99% missing. Utilities 99%, no provision. Just we are having some provision afterwards. So whenever you want to inspect, you should have these things, access equipment, so that we can see all the components properly. Measuring equipment we should have, recording equipment, and safety equipment. So these 4 things required whenever we want to visit or we want to inspect some bridge. These are some details for the access equipment. I will go in very detail after some time. These are the recording equipments. And in codal provision, you will find what we have to inspect, that all things are given. And after inspecting, you have to give some plan. Yes, these elements should be get rectified within a prescribed period of time. Just as expansion joint, bearing, crack, damage, bearing coat, strengthening works. So we have to specify is for the severity of the condition of the bridge. And then you have to give one certificate. Yes, our team has visited on such and such date. And you have to certify basically. If you see the inspection accessibility, we are in need of mobile bridge inspection in it, main lifters, ladders, sometimes drone is also required. Sometimes inspection trolley if cable stayed bridge is there, boats, rafters, and if you want underwater scanning, then some robots and some divers. So these are all accessibility. You can see we are having like this mobile bridge inspection in it. Yes, there is 3 arms, one is horizontal, one is vertical, and one will go at the bottom. This is one type of mobile bridge inspection in it. There is a complete platform, so we can say platform type. And there is bucket type, second type, just 2 or 3 person can go and see. Here flexibility is there, more person can go and work peacefully. So this is mobile bridge inspection in it. Sometimes we are using drone also. Sometimes Hydra with moving platform, that platform can down and we can see from the bottom. So that can be done. Sometimes we have to use motor boats. So whatever the means, we have to see the bottom of this structure. The main motto is, let us see the girders, deck slab condition, bearings, bearing pedestal, pier heads. That is our main motto. So sometimes you need this type of arrangement also, so that here that mobile bridge inspection unit, some mobile bridge inspection unit will not work because this space between these members are very, very less what we require for that particular mobile bridge inspection unit. So in that case, Hydra and this moving platform will work. Yeah, sometimes you need boat, motor boat, any type of boat you can have. Sometimes even rafters you can use. So by any means, we have to see the structures. If say this type of structure is there, then you need a very good main lifters. Yeah, you can see if height is 20 meters, 25 meters, then the lifter quality should be also very good. You can also have mobile bridge inspection in it, and you can also have drone also, so that you can see all the components. Sometimes you should go with a motorboat also, so that we can have look of the condition of pier, and also some NDT work can be done. This type of main lifter is also required, generally which municipal people are having or changing of bulbs. So that can be also used to go inside the box cutter. So by any means, we have to reach up to the various element of these structures. I request all the engineers kindly have this type of walkway, so that we can see the bearings. You see, in railway, they are adopting this one. In every ROB, you will find there is walkway. But in highways, we are not having provision. Let us have this provision mandatory. I request our some engineers who are attending from IRC, or many senior colleagues and senior engineers are there, who are member of the various committee of IRC. They should have mandatory requirement for seeing the bearings. Actually, this is very much compatible. In railway portion only we are doing, but we are leaving for the remaining portion. Even we can have this type of walkway also. It is also very much useful. So we should provide something, because always having mobile bridge inspection in it, or main lifter with hanging platform, this is not possible. If you provide this type of, then inspection will be very easy also, and economical also. You see, earlier we have to go like this, then inside, whatever the 10 meter, 12 meter height is there, we have to use this type of ladder, you can say. Then this mobile bridge inspection we started using around 2010 in India. Yeah, it is really very comfortable. You can have this type of one horizontal arm, this is vertical arm, then this is again horizontal arm, and it will move between pier to pier. Whole span you can inspect, then again turn it 90 degree, and it will go to the next span. So really it is a very much easy using mobile bridge inspection unit. We have to also take care, there should be some inspection hole in the box girders particularly. Sometimes we are not having any space to go inside the box girder. You say these two box girder is only having 1 inch or 2 inch space between the girders. And so you can't go inside, and we have to make provision to go inside of the box girder, because it is very much essential to see what is the condition of deck slab from the bottom. From top, we can't able to see due to wearing coat. But you can see, if you go inside, sometimes you will find like this. And if this is the condition, then definitely that shear punching will be there in the deck slab. So it is really essential to have a inspection hole in the box girders. And the size of the inspection hole should be also proper. Whatever the codal provision, that is 600 millimeter dia, that should be maintained, because we are finding difficult sometimes to go inside the box girder. The inspection hole is there, but dia is only 300 millimeter. In that case, you can't go inside. So that is the case in some cases. You can see here, this is a really very beautiful arrangement, accessibility, you can say, to have look of the bottom of the girders, box girders. You can see any bearings, you can see the cracks on the waves, you can see the cracks on the soffits, everything you can see. Yeah, if say this type of bridge is there, you should have mobile bridge inspection in it. You should have main lifter also, so that some span can be covered from this main lifter and hanging platform. And to go and see the PS condition and do some non-destructive testing, we require boat also. And you see the pier head, that pier head is having around 7 meter, 8 meter in that case. If this is having a span 130 meters, means 65 meter on this side, 65 meter on this side. So this height will be 6 to 7 meter. Then a very big ladder is also required inside the box to see the condition of diaphragm, because sometimes there is so many cracks in the diaphragm also. So all these things are required to inspect the structure. You see, this gap is around 2 inch, but after 5 or 10 years, if we are not seeing this gap condition, you will find that this is covered with some debris, sand, etc. And water is going both sides of the box garden. This portion is covered, water is coming this side and the next. So we should have some provision to clear this one. This is only due to our expansion joint seals are not working properly. If you are maintaining expansion joint seals, this condition will not arise. But really, for last 30 years, 20 years, we are not maintaining anything. Even that drainage spout and expansion joint, these two things, which is really very dangerous for the condition of the bridge. And we are not maintaining that for 10 years, 25 years, 30 years like that. So that is the main contributor towards the deterioration of the structures. You can have mobile bridge inspection in it and you can monitor any structure, even some barrages. Yes, we can monitor. You can see here we are using rafter to see the bearing condition and see the bottom of the girders, bottom of the deck slab. So you have to have something to see the structures. Nowadays, 4-lane, 6-lane, 8-lane structures are there. Sometimes there is 2 carriageway, and that is different, having different support condition. In that case, to save the time, we can put our mobile bridge inspection unit in between both the carriageway, so that once you can see this one, say right carriageway, and in other case you can see the left carriageway. So this is also good one to save the time. You can see the bearing both the sides, but the provision should be there in the mobile bridge inspection unit. In some mobile bridge inspection unit, this type of rotation is allowed. In some mobile bridge inspection unit, this right movement is not allowed. So that depends on the what type of facilities is there, provision is there in the mobile bridge inspection unit. But it is very good if you put in between and in both the arm, not very big angle, around 15-degree angle. In general, the movement is allowed. Yes, you can see here. This is really very beautiful to see any structural component. Yeah, you can have this type of structures also inspected, arch type. Here, this is box girder. You can go inside through main lifter and you can have that is twin cell sometime. So in both the box girder, the separate team can go. Yeah, ladders is also essential. Yeah, this is inspection of Dwarika actually. So you have to go really inside the bridge, then only we can. This is our senior colleagues. Even Dr. Pal is there in that time. He also visited. I request all the engineers kindly go through this Dwarika Expressway. Really, it is very good structure and you can enjoy. But not from the top. You should come through the service lane only at the bottom. If you are going from the top, you will not enjoy the Dwarika Express. We have to go from the bottom, and even you can have a look of the tunnel there near the airport. Very good tunnel. So all the civil engineers should visit these structures. Yeah, this is that tunnel actually. Just there we are doing the structural safety audit at that time. If you see the causes of distresses, there may be 3 types: design stage, construction stage, and service stage. Design mistakes may be loading specification, material specification, design codal provisions. Sometimes all are good, but drafting mistakes is there. In drafting, instead of say 22 mm or 32 mm dia, only 12 mm dia is written. So you have done very good design, but let us have this also in consideration. Drafting mistakes also before issuing a drawing, let us check drafting mistakes. Then construction stage, yes, poor construction practice, lack a complete cover. Sometimes we are getting zero cover, or this cover is only up to 0 to 15 mm. Poor compactions, that is also there. Inadequate curing. So these all the things are coming. Lack of quality control. Nobody is going there to see the RMC plant. If you ask, they are just telling we are taking concrete from the RMC plant. But they don't know how it is coming, what is the slump required at the RMC plant, and what is required at the site, and how they will maintain. Those things should be seen. Otherwise, really very difficult. Whether they are adopting moisture correction factor or the aggregate, sand, etc. Those should be seen. Insufficient site supervision, people are not having time to see the sites, what is going on. So this is a really big problem. During construction, if we are doing very carefully, we will definitely get the service life 70 years, 100 years, whatever our design period, by maintaining it properly. So that is the really very, very essential stage to involve all the people. Then service stage, overloading is the main problem. Change in use, that earlier it was only the say village road, major district road, then some state, then it becomes to national highway. That is, we are changing, upgrading that, but without any rehabilitation strengthening scheme. So that is also very dangerous sometimes. Environmental factors, definitely during maintenance period, if you are neglecting the maintenance of expansion vent and drainage spout, then this environmental factors will do more effectively deterioration. Structural movement, sometimes some settlements will be there, and lack of regular mention. Just I explained the expansion vent and drainage spout. So to avoid any maintenance or bare minimum maintenance, it is essential to follow the golden rule of concrete technology, 3 C's. That is well compacted, well provision of cover, and well curing. This 3C, if we follow, then our structure will definitely go for 30 to 100 years. You see, we are neglecting cover also. Say in case of buildings, if you see the 50-year is the design period, say the cover required is 20 mm for a slab, and if you provide just 2 millimeter less cover, means 18 mm, then 20 mm cover will give 50 years service life, and this 2 millimeter less means 18 millimeter cover will give only 40 years. So this 2 millimeter cover difference is creating 10 years difference in the age. So we have to maintain the cover properly during construction. So if you follow good compaction, good cover, and good curing, and of course good mixed design, that is always there. If mixed design is not good, then nothing will work. So if follow this thing, really that structure will be strong and durable. You see, this is the scenario within 1.5 year, just after 1.5 year after construction. This type of punching here. And if you see what is the regions, yes, you can see and you can tell after seeing the site condition, the cover is 0 to 15 mm. The concrete mix is not proper, definitely. And the thickness minimum provided 200 millimeter, but at the site, if you measure after taking 6 pours, you will find the average thickness is around 160 mm in this case. So minimum 200 millimeter deck slab thickness was required, but average is if 160 mm, and there is no proper compaction, no proper curing, no proper cover, no proper mixed joint, then this will happen. So within 1.5 year age, before 2 years, this bridge is having this condition. So conditions was such that this shear failure, you can say, took place at many locations. Then we have to demolish the deck slab. That is the only option. If there is so many shear punching zone created on the deck slab, it is better to demolish the deck slab, because rehabilitation of this type of weak, very weak, instead of M40, if it is giving M15, M17, M20, then it is not desirable to strengthen. So it is better to replace the deck slab. We can see in some bridges you will find the drainage spot are really very badly located. Sometimes it is just on the supporting element, just above supporting element. Sometimes it is just above pier head. You will find the location of drainage spot here. So these things should be avoided. The drainage spot should not pour any water on the structure itself. It should be away, not in any element. You say this is the pre-stressing cable, but this drain provided it lateral drains, and there is no projection in lateral drain, and all the water is coming on the cable, and after 20 years, 25 years, 30 years, you will find this type of condition. So we should take care properly this location of drainage spots. And you see here, you can see light from the bottom. There is no seal in 95% bridges. There is no expansion joint seal. Stiff seals are not there. That is just like that. If that is there, that is badly damaged. So water is continuous coming on the pier head, and it is disturbing all the bearings, bearing pedestal, pier head. You can see after 10 years, the condition will be like this one, because we are not maintaining expansion joint seals. Yeah, you can see it here. There is no projection. Let us have some projection here on the drainage spot at the bottom. This should be like this one, just adjacent I have shown. So if some projection is there, then this will not happen. So this is this we should really adopt. Yeah, you can see this is the condition. There is no projection. After 5 years, you will find this type of spalling, and after 10 years, you will find this type. After 15 years, that pier will also get cracked, and after 20 years, whole flyover or bridge should be demolished. So in many structures we are finding before 25 years, the withering action is so severe that you have to not consider for rehabilitation repair work. You have to demolish the structure. And this is only due to two reasons. We are not maintaining our drainage spot and expansion joint. Only very small thing, but very great contributor towards faster effect of withering action. In 90% bridges, you will find there is no structural problem. We are having only withering action problem, and that is predominant. Condition is so worst, we can say, so severe. Sometimes we have to recommend, yes, let us demolish this. Only 10% cases you will find the structural problem. You can see we are not maintaining expansion joint, say at the beginning or end of the bridge. Then what happens? You will find this type of erosion of soil from the below. And sometimes if that is some abutment solid type, some shallow foundation, you will find tilting of that foundation also. So we are neglecting expansion joint, and we are creating ourselves this type of problem. Yeah, sometimes we are taking decision. Earlier there was actually railing type, steel railings were there. All of a sudden decided, let us have crash barriers. But these brackets were not able to take the force, the load coming through the uh, crash barrier. And due to that one, the whole crash barrier fallen down. So actually before alteration of anything, we have to see whether whatever the load we are putting on the structure, whether it can be sustained or not. So that should be there actually. Otherwise, it is very difficult to have stability of the structure. And sometimes this type of failures happen. You can see during concreting, if you are not doing good compaction, curing, and we are not taking precaution for the high temperature, high wind, so this type of things happening. Sometimes you have to see the bearings, elastomeric bearings, and if bearing is having this type of cracks, it means elastomeric support is not good. You can say towards bearing, and you can reject this type of bearing. If cracks are there, bulging is uniform. Okay, from bulging there is no problem in this one, but the cracks are there. So this should be rejected. Say if bulging uniform, that is allowed. But if bulging is local, this is locally bulge out. This is not allowed because the bonding between this steel plate and this elastomer lost here. Due to that, this is the local bulge out. So this is also comes in the category of failure. So these two cases we can reject. And third case is if there is too much shear, say if thickness is say 100 mm and shear is more than 50 mm, you can reject that one. So three cases. Sometimes you are not taking precautions, whatever the instruction given on the drawing, that is say first stage of pre-stressing within 7 days or having strength of concrete so and so. After 14 days are having strength of concrete so and so, second stage of pre-stressing. After 1 month or after 45 days, third stage of pre-stressing, that we are not taking care. And you see, in this case, at the age of 30 days only, that pre-stressing were not done. And in the morning, 5 a.m., some tractor trolley came here, hit the scaffolding bar, and within 2 hours, this box girder collapsed. So, if the pre-stressing has been done at that time, this can be avoided actually. The reason is that they have not done any pre-stressing in 30th days also. All things were there, jacks were there, pre-stressing cable were there. Only the pre-stressing activities has not been done. So one tractor trolley hit that one, that supporting cross, and within 2 hours, whole girders collapsed. If you do the back analysis, the if you remove the 7 post from the center, you will find that this box girder is not able to take its own dead weight. So that was the reason. That's why whatever the pre-stressing instructions given on the drawings, we should follow that one. If you are not inspecting, say sometime the cracks will be like this one. And if you neglect for a long time, it will come to the collapse. So inspection is very much essential. Time to time, at least within a year, once we have to inspect. The good work has been done by the PWD Odisha. Odisha government has done good work. Actually, around 350 bridges they have given to CRRI for inspection. And what happened? It is not moving. Now moving. Okay. Okay. So there around 350 bridges were there, and it is scattered. say there is 40 divisions, and you will find in some division 10 bridges, some division 15, some division 3 bridges, some division 5, like that. You can see very big bridges are also there, major bridges are there in Odisha. Yeah, this is the Bankanal bridge. You will find all type of structure is there. Suspended span is also there. Balanced cantilever is also there. Simply supported is also there. Yeah, you can see cantilever type. Suspended span, simply supported. So in one bridge, we'll find all type of structure. Really, on seeing also, it looks very beautiful. But in suspended bridge, the inspection is difficult. How to go inside? You will find only 2 holes there at the both the ends, and from that we have to go. So through mobile bridge inspection unit, you can come like this one. Then in that hole, we can go inside, and on going there, we'll find this type of, so that we can go in both the side. The one is the suspended one, second is the cantilever, continuous cantilever. And there we can see whatever the bearings system is there, and you can see inside also. You can go inside and see the box cutter cracks in the deck, wave, or some shear punching already there. Some is going to have within 3 months or 6 months. So all the things can be inspected. Yeah, you can see these are the condition of bearings, supports, and sometimes actually you see in bearings, especially in, we can say almost in all India, not in a particular bridge. Actually, there is 2 types of temporary supports. One support during installation we are providing at the site, and one temporary support provided by the bearing manufacturer, so that all the elements should be proper taken care up to the installation. But in 95% cases of bridges, we will find that whatever the temporary supports provided, just like this one, wooden blocks, that is not removed even after 50 years of age of the bridge. It means we are not giving any priority for this work. In 50 years, we are not having time to remove this temporary support, whatever we have provided during installation of bearing. This should be removed before allowing the traffic. It means for last 50 years, if 50 years is the age, the bearing is not working. All our bearing is working as a fixed bearing only. You see, this is the plate provided by the manufacturer just up to the installation. After installation, we should remove this plate, and we should join these 2 rollers with a horizontal tiling. Here tiling is missing during service period. Even they have not provided at the beginning. That was like this only. This plate is gone outside. So this is there. So this temporary support should be removed, and there should be one tiling this side and one on the back side, and there should be one pin and nut. This is leading to failure in some cases. Say 5-6 months back, this Ahmedabad bridge collapsed. Here, this tie link has not been seen for last 30-35 years. And what happened? This tie link is not there. And this roller, they are behaving independently. And the displacement of roller took place, and it is just coming at the end. Just it was waiting for one jerk, and that jerk is given by one truck, and that roller has gone inside the river. So if you are not inspecting, then someday really this collapse may happen. So I request all the engineers, kindly have a look of your structures every year, at least If this type of situation is there, you can avoid that one. If inspection could have been done before that one, then properly that can be done. So really, these three things we have to see during inspection, whether the temporary support has been removed by temporary support by installer, whosoever is installing that one, temporary support provided by the manufacturer of bearing, and whether these tie plates are there or not in case of roller rocker bearing. And in rocker bearing, we have to see this nut bolts also. You see, this bolt is here, length is too high. It is not giving any space to rock the rocker plate at the top. Both sides you can see. And this is the condition at the back only. So all the bolts, all the four bolts, they are just holding the rocker. So there is no rocker action. So you will find that in 95% cases, our bearing is not working. And we are doing load test and telling, oh sir, this load test theoretical is 20 mm and our is coming only 9 or 10 mm. How it will come 20 mm? If your bearing is not working, this is foolishness of doing the load test. So I request all the engineers, before load test, just see your bearings, then only allow for load testing of the structure. That's why I'm telling 90% load tests we are doing us. If bearing is not working in 90% cases of bridges, how we are doing that load test? Whatever the load test is, that is useless. So one should see whether your bearing is working or not. Not working, then first make the bearing should work properly. Then only load test should be allowed. You can see here, this is roller bearing. Okay, very good. Tie plate is there. But you see, there is no anchor bolts in both the sides. Here also no anchor bolts, no anchor bolt. Here only one bolt is there. There is no nut also. And I don't know on that side. That side maybe also same thing. So at least the anchor bolts one can see. You can see here for this rocker bearing, this bolt is too long. It is restricting the rotation of the rocker. And it is in all bridges, not I am showing this one, so this only. In all bridges, you will find like this one. Here you see the bearing manufacturer has provided just one plate. This should be removed. This is temporary plate. But you see, after 40 years, 45 years age of the bridge, this plate is there and this has all rusted due to continuous pouring of water through the expansion joint. And you can see we have not removed the temporary support provided by the bearing manufacturer. We are not having time to see our structures. That is the main reason. You can see sometimes this type of cracks are there in the deck slab. And this is clearly indicates that you will have CR punching within 3 months to 6 months. If this type of stark radial cracks are coming, then there will be mapped or spider cracks all around this one. It clearly indicates within 3 months, 6 months, 1 year, you will have CR punching. So if you inspect, you can have some time to strengthen those things and the CR punching can be avoided. So inspection is very much essential, and proper inspection, not only going to the upper side of the bridge through the some vehicle and just at the A1 and A2 side taken 1 or 2 photographs. You have to go and see how the bearings are, how the anchor bolts are, whether that nut bolts are proper or not, whether that restriction is there, whether that temporary support is removed, both the temporary support provided by the manufacturer and provided by the installation whoever done at the site. Then actually for this cantilever brackets, this is the critical zone actually where the cantilever brackets are just meeting to the pier. And you see there is the cracks and this cracks prolongs down. So this is the very much essential to go and see all the cantilever bracket that is supporting. In this case, there is 4 cantilever arms and these are supporting the main girders. So you have to see what is the condition, this crack, what is the depth of this crack, what is the width of this crack, so that we can save with proper strengthening work at proper time. Yeah, you can see here also, the temporary support has not been removed, whatever temporary support provided by the manufacturer. So that is there. Another, instead of tie plate, there is tooth plate also. This is also allowed. In this case, both the vertical tooth plates. And here, the translation is through rotation. This tooth plate will rotate and the whole girder will move longitudinally. So that is there. This is also allowed. But in here, you can find one tooth plate is missing. Here also, you will find some nut bolts are missing. So those things should be seen during this inspection. Here you can see, yeah, here you can find that nut bolts are missing. Here, tooth plate is missing. Here you can see bearing pedestal is cracked. Here you can see temporary support is there in the rocker bearing. So here you can see rocker bearing movement is restricted. So these things should be seen. I request all the designers kindly have this height down. This should be in the comfortable height, around 1 feet height, not 1 meter. If someone has to inspect the box girder, he has to take 2 ladders and then only he can see. And this ladder to be taken twice to move one girder to another. So I request all the designers, all the approving authority, kindly have this point. This should be down at the comfortable height so that one can go and inspect. In this case, we will see the inspection hole is only 300 millimeters. Then how one can go inside to see the structure? So that should be also taken care. It should be minimum 600. One thing should be also remembered, whenever you are doing widening cases, let us have strengthen the old bridge also. You will find that widening has been done, the work is going on for the new bridge only, but we are not having even a look on the old structure. What is its condition? After 2 years, we have to again demolish. If that is the case, you have to take together some strengthening work for the old structures also before taking the widening. But in 90% cases, we are finding that the widening work has been done, but the old structure is badly, severely affected, and that should be in the stage of collapsing sometimes. So that should be taken care. In many structures, you will find too much honeycombing at the bottom. If you just hammer, you can have a look of all the reinforcement. What is the diameter? How many reinforcement at the bottom layer? How many? You just hammer sides, and you will find that how many layers are there. So the concrete is not reaching up to the bottom. That is the also reason for one of the failure actually. And many bridges are having this condition. In all India, I am not talking for a particular bridge because I have inspected more than 3,000 bridges in all India. And I really found that in almost all the states, the same thing you can see. You are having temporary support on the bearings. You are having this type of honeycombings. Same thing. Yeah, you can see if this is the suspended span bearings, we have to see properly. If this is one end is having, but in this case, I have seen the next end is not having. Here you can't see. This is the photo from the next side. There you will not find the type plate. And 30 years, 40 years, 45 years, our expansion joint is leaking, and this is in very bad shape, and this is total move, and whole the suspended span is just lying, you can say, resting on the cantilever arm. Means the bearing is not effective. So really we have to do inspection. Otherwise it is very difficult. In many cases you will find this type of bearing, this stage, cracks. This is local buckling, bulging. So in that case, if this is the case, we have to replace the bearing. Then you have to do all the operation, lifting the structures, through jacks, putting new bearings. And generally, due to this leakage of water, you will find that rusting effect. And for elastomeric, you will find this type of cracks in very, very young age. Generally, 15 to 20 years, we are thinking the elastomeric bearings will go. But within 5 to 10 years, you will see this type of condition in many bearings. And if expansion joint and this drainage is maintained, in some cases at the age of 40 also, the elastomeric bearing is working and we are not recommending for replacement. So you see the expansion joint and the drainage spout. These two things we cannot maintain. That's why these weathering actions are too fast. You can see how the bearing can be replaced, and it is very, very difficult operation. You can see some cases you are neglecting the grade of concrete in the bearing pedestal, and due to that you will find that crushing of bearing pedestal took place, and we have to remove the bearing, replace the bearing. So really one should take care the proper grade of concrete for bearing pedestals also. Sometimes we are thinking in the very small quantity we need, and we are putting any grade of concrete in the bearing pedestal. So it may lead to this type of failure. So let us have in mind that this is the very essential component of the structure, and that should be taken care properly. Here you can see this type of bearing is there. This is roller rocker only. This roller, various 4 rows of rollers, 3 rollers in each row. This is also roller type, but this cut roller. This is known as cut roller, only a small segment. So sometimes segmental roller bearing also we can say this one. Rocker come cut roller or rocker come segmental bearings. So this should be seen actually from the very, say 1 meter, 1.5 meter distance. And we have to do NDT also during inspection. The standard tests that rebound hammer, UPB, and your some core samples also, cover meter tests also, carbonation tests also. And I request all the engineers from the rebound hammer, don't recommend the crushing strength of the concrete. Some people are just having, oh sir, very good result. Rebound hammer 45, 50 is coming. It is very good. No. Rebound hammer is only reflecting 1 inch cover hardness. So until unless you are having some cores, don't comment about the strength of concrete, grade of concrete. This is really blunder mistake. And I am finding intentionally people are not taking core. And with rebound hammer, they are recommending the crushing strength of the. It is really horrible situation. You can't give any grade of concrete until unless you are having supported with core value. Then correlation we can take. If this is the rebound hammer and this is the core strength near that one, then we can correlate. Okay. For other parts, if you are not taking the course from other parts also, but then you can have. Otherwise, only on rebound hammer value, you have to not comment about the strength of the carbonation. We are also taking at the site. Sometimes you see the bearings, they are having any bearing pedestal. You can see all the sizes of bearing pedestal are different. And sometimes third location, And you can say bearing location, single bearing, and it is also not centrally placed. So negligence is really leading to some collapse there. Sometimes you will see this vegetation grow too much. That should be also avoided. Yeah, this is general weathering action. Sometimes overloading in case of mining of sand or mining of aggregates. And really, you can see grass weight 3XL 50 to 60 ton, around 2 times more than what is allowed. 1.5 to 2 times what is allowed in 4XL. 5XL also you can see 1.5 times more than what is allowed. So really, in case of mining area, the people are taking really 1.5 to 2 times of grass weight, whatever allowed. So that is also some of the reason. If you want to rehabilitation scheme for any bridge, really these are the good code. IRC SV40 for Indian scenario, European code EN 1504, ACI 562. If you want really good knowledge for this one, go through EN 1504, and it is having 10 parts, and all parts are well defined in different themes, and one should go through all these 10 points. Then only you should have very good knowledge. You can find these are the prevailing practice. Generally, we are adopting in rehabilitation. That is polymer mortar, concrete, patch repair, pressure grouting for cracks and honeycombed area, jacketing, short kitting, uniting, external pre-setting, and fiber laminates and wrapping. So these are the general practice for rehabilitation. But the surface preparation should be proper. Otherwise, it will not work. You can see you have to, if there is some corrosion, we have to expose up to the concrete, up to the reinforcement level. Then beyond that, at least 1 inch, so that that should be properly cleaned. And then after cleaning, rust removing, the whatever the concrete will be poured, that should have a good contact with the parent concrete. So that should be done properly. Then pressure grouting, generally we are using for cracks and honeycombing area also we are using. If body honeycombing is there, in cracks you can see this type of work that pressure grouting will do. Jacketing sometimes you are doing, but jacketing you see, if we are having just a weathering action, then okay, 100 mm jacketing is okay. In weathering action, we will find the vertical cracks will be there, not the buckling of the pier. So in that case, we can do jacketing work. Yeah, per column we can see this type of one can do. Sometimes short kitting, uniting we are doing. Sometimes external pre-stressing, you have to have provision for diameters also, for anchor of pre-stressing cable also at the ends. Yeah, this is one of the simplest way for the simply supported bridge. We have to give trapezoidal shape for the pre-stressing cable. This is the some specification for the FRP. Yeah, you can have sometimes this type of FRP to avoid the shear punching. Sometimes we can have this type of ISLV section in between, so that we can avoid shear punching. If cross diaphragm is having many cracks, we can provide some plates and just weld one plate both the sides, and then we can have some drills, and through bolt and nut we can hang that one properly, so that if cracks are there in the diaphragm, we can have this type of, or we can go for a FRP. Yeah, there is so many possibilities there. we can put this type of FRP rafts. I was telling this one actually. If this cantilever arm is there and it is supporting main girders, then this is the critical zone actually where the cracks are there. Then we have to have very good strengthening scheme to avoid the failure of this arm actually. Sometimes, and really if a proper rehabilitation work if not going to take place within 10 years, you will find so many bridges going to collapse. This is very beautiful bridge, but having this type of severe cracks actually, you can see here, the cracks are at the just joining with pier. There we will find, and that crack is across the thickness. So it will prolong up to the bottom, and sometimes it will lead to the collapse also, because it is around 40-45-year old structures, and so many in India, and they are all having cracks, but the severity of cracks is different. So I request all the engineers, if they are having this type of supports in their structures, kindly have a look for these cracks across the width and across the thickness both. And let us have good strengthening scheme at proper time. Otherwise, someday that bridge will definitely collapse, because they have not designed for this high load, whatever the prevailing at present, whatever I have shown, the load carrying capacity 2 times, 1.5 times the vehicles are taking, the trucks are taking. So it is very difficult actually for that load. To overcome that, the proper strengthening work should be there, that jacketing should be there, that laminate should be provided, FRP laminates, so that it can be saved. Say girders or cross girders, you can provide for flexure laminates at the bottom, and FRP rafts you can provide at the shear zone. So this should be done, but at the proper time actually. If we are too late, then the total cost will be also too much. You can see this type of structures, but after rehabilitation in time, you can have very good look also by doing this rehabilitation work, and it will enhance service life. So, but you take these things in proper time. Here you can see, purposely we have put horizontal lateral drainage support away from the structure, because you will find otherwise here all this is falling and exposed reinforcement. So it is better to have, if lateral drainage spot is there, let us have 1 meter projection. What is there? 1 meter pipe outside. Yeah, I am requesting for this type of structure. Let us have look as early as possible. Otherwise, this may lead to collapse due to anything. Number one is structurally from this one. Number two, their rollers are in the critical stage, and it will go in the river with any push from the heavy trucks. So especially we have to take care for this structure. So this is distress mapping actually. If whatever the cracks, whatever the distresses we are seeing, we should have in map, in drawings. So crack mapping should be there. Yeah, for this slab you can see so many cracks. During inspection, you have to take some dimension measurement also for girders, for bearings, so that whatever the replacement is required, we can have, and whatever the calculation required, we can do if dimension is there. Yeah, for this type of structures, we have to have jacketing as well as laminates, both laminates and FRP rafts also. So we can have a good strength. Yeah, this is another way for cross. In box girders, you will find so many cracks on the structures. You have to have FRP, and we can provide this type of. You see, so many cracks are there. That is first pressure grouted, and that laminates foot of the length at the center, and one third you can put your wrapping system, FRP wraps. So, and this drainage spot, we have to have at least half-meter projection. Sometimes, if it require more, we can go for external pre-staging also. So that is there. Yeah, you can have both FRP refs as well as external pre-staging. It depends on the what is the requirement for the strengthening work. So you can see refs also and FRP. Yeah. So this type you can see afterwards. This is another way of inspection. We can have a structural health monitoring system also. So there is so many bridges instrumented earlier, and some of the instrumentation work is going on. For these parameters, all the 8 parameters, we can have sensors and we can find out these parameters. Strain, stress, temperature, deflection, lateral pressure, tail, crack width, corrosion, acceleration. We are having sensor for all this one. This can be installed at the appropriate place. You can see this is the strain gauge, embedded one. This is the surface mounted strain gauge. This is weldable type strain gauge. If steel structure is there, you can have this one. You can put sensors in different orientation so that we can find out strains in different direction also. So this is some view of the strain sensors. Yeah, this Varanasi bridge, Ganga bridge, which is known as Biswa Sundari. This is instrumented long back, 1990 to 1995. In that era, a very beautiful bridge, having good instrumentation, that well foundation, PR, superstructure, all instrumented for one span. So you can see any parameters. Yeah, to know the temperature gradient and maximum temperature during hardening, this type of sensor, temperature sensor installation has been done during construction in the year 1993. And this is the first instrumented bridge in India. It was started in 1990 and the construction activity took place 5 years. So in 1995, the whole instrumentation scheme was implemented. It has to go with construction activities only. So we have to wait for every stage of construction before putting the sensors. This is temperature gradient. So in the codal provision, there is temperature gradient allowed is 20 degree and maximum temperature is 70 degrees centigrade. But I request all the engineers, if your thickness is more than 2.5 meters, you should have very good control in your concrete mix. You should go for ice cured concrete and for steam curing. Otherwise, you are both the provision, whatever provided in code, that temperature gradient should not be more than 20 degree, it will be violated. Maximum temperature 70 degree, it will be violated. If thickness is 2.5 and we have not taken care of ice curing, water for making the mix and that steam curing. This is some result actually. You can have very good result if you put some sensors. These are the sensors put across this is tin cell and sensors were put at different places and you can have very nice graph. Within 3 to 5 years, you will find shrinkage and creep variation. Thereafter, we will find that strain graph will be stabilized. So it will go parallel. Only the climatic condition changes will be there. Yeah, this is just a single cell box girder, strain variation during pre-stressing. There were 17 pair of cables and how the strain varies, that is shown here after pre-stressing of each pair. So you can have good data to compare with the design parameters that will come through instrumentation only. You can have what is the maximum temperature gradient. For that, you have to see what is the temperature profile shown by different sensors. You can have good study the behavior of any steel structures by putting some strain sensor and some some accelerometers and some differential transducers, actually displacement transducers you can put, and you can find all these parameters. So instrumentation is giving a very good support for the new designs, and you will find so many data. Then you should use database management system also for the instrumented bridges, and it is very easy to handle with database management system. You can see any result of any component, whatever the well foundation, well cap, pier, etc. Yeah, through instrumentation you can monitor whatever the external rehabilitation work is going on. Say here, external pre-stressing work was going on for the very bridge. So there the strain, deflection, etc. will be monitored after every stage of pre-stressing. So that can be done only through instrumentation. So actually the main things you can see, if you want our structure should go for 100 years, let us have, before opening the structure, there should be a structural safety audit, so that whatever the defects existing in the structure, that can be known at the beginning only, and that can be rectified. Then we have to launch Mission 2026. That I will tell what is the Mission 2026 in next slide. Yeah, this is the Mission 2026. There is 11 points. If we follow these 11 points, our structure will definitely sustain 100 years. That is guarantee. First one is very easy, clean and maintain drainage spout. This is very easy to maintain, but it is contributing 50% deterioration on this structure. Clean and maintain expansion joint. You see, these are the two things which is giving withering action on the structures. That's why I am telling there is only one line for maintenance. There should be no interaction between water and the structure. And that can be done through a good drainage spout and maintaining the expansion joint seals properly. If you can do these two things, your structure will definitely go above 70 years. Clean and maintain water logging on deck slab. Sometimes you will find whenever there is some rain, you will find water on the deck slab. And this concrete is a porous material. And if water is there, definitely it will go down and the rusting will take place for the main reinforcement, pre-stressing cable, whatever. So that is there. Clean and maintain the excessive dead load. If you go and see what is the depth of BC, you will find generally if age of the structure is 30 years, we will find 4 or 5 layers above that one. Means you add every 5 to 6 years, 50 mm thick. So after 30 years, you will find it is around 300 millimeter, 250 millimeter, 200 millimeter. So let us remove all these things. Whenever you are doing BC, remove all the layers and only one layer will be allowed. Otherwise, this dead load is too much on the structure. We are designing only for 50 mm BC. And we are putting 200 to 300 millimeter thick. So that should be avoided. Clean and maintain vegetation growth. You will find green India in structure. Green India is not allowed in structure. You have to clean green vegetation growth. There should be no vegetation growth on the pier heads, near the expansion joints, on the location of drainage spout, near the abutments. So that should be avoided. Clean and maintain abutment piers. Sometimes you will not be able to see the bearings. There is so many debris all around that one. You can't see the bearings. Let us have clean pier heads. Clean and maintain bearings. This is having a very big meaning, what I am telling. Clean and maintain bearing means you have to remove temporary support provided by the bearing installation agency. You have to remove temporary supports provided by the bearing manufacturer, that should be there. That is the clean and maintain bearing. Then if metal bearings are there, roller rubber, we have to put one proper box and let us fill that box by the proper grease as per IS 1002, not any grease, whatever the grease available in the market, we are putting there. No, that is not the good way to do work. We have to put grease of very low viscosity, that is given specification is code ISY 1002. Then clean waterways silting maintenance. Actually, if you see out of 3, 4 box cell, if say small structure we are talking, out of 4, 5, only 1 or 2 is working. Other 3, you will find silting effect are there. No water is flowing through that one. Or there is too much vegetation growth. So let us clean that one. Clean excessive live load and maintain it. This is especially we have to take care the stresses where mining work is going on, sand activities, sand mining, aggregate minings that is going on. So there we have to let us have one day look how the weights are taken by the different type of trucks. Then you can realize that whatever the load taken by these trucks, that is 1.5 to 2 times what is allowed. Then for special structures, yes, you have to see the cable and anchor ends of the cables and general repair. Whatever the clean, exposed reinforcement, damage, honeycombing, cracks, erosion, protective apron, these all should be maintained time to time. So if we follow these things, I don't think we will be behind the global scenario. Definitely we will catch 52 within 5 years. If we all follow, within 5 years we will be the global scenario. That is average collapse age of the bridge, 52 years, that we can achieve. But if we are not going to follow this one, we are going down. If you see the last 10 years data, now our average collapse bridge age is going down. It is not 34.5, it is below 30. So we are going down, not rising up. So I request all the engineers, kindly follow this small thing and let us contribute a lot for the country. Thank you, everyone. Thank you. Hand it over to organizer.
Vyas?
Any?
Hello, Vyas? Only 3, 4 questions because
Yes,
now yes,
exceeded the time limit.
just 3, 4 questions.
Okay, sir. Mr. Manjeet Singh Ora asked, please throw light on the latest equipment for structural health monitoring of bridges.
There is so many. Actually, we have to see what are the parameters you want to monitor. Actually, if you want to monitor strain, you have to put some strain gauges. If you want to monitor, say, pre-staging force, we have to put load cells. But this load cells should be put before stressing the cable. Then only that load should go through that instrument. Then only it will give the reading later on. Like that. So it depends how many parameters. Whether you want to monitor, say, corrosion, you have to put corrosion sensor. I have shown 8 type of parameters, and all these are required as per your objective. Whether you are interested in only vibration measurement or dynamic test, yes, then you have to install accelerometer. So all the sensors, whatever I have shown, that is required, but as per our objective.
Thank you, sir. The other question is, are there any IRC standards or guidelines available for bridge rehabilitation following an inspection? What criteria are used to determine whether a bridge requires repair, sampling, rehabilitation, or complete replacement?
Yeah, actually now our IRC SP40, this new edition, that is having very good elaborate. So everyone should go, whosoever is going for repair rehabilitation, they should follow. Now it is a modified one. Earlier, there is only basic idea, but now it is get elaborated and at par with our European code and ACI code, you can say. So now you can have a very good idea. So one should go IRC SP 40 and 2024 version.
Thank you, sir. How effective is the use of carbon wraps for cold joints, cracks in slab soffit?
You see, this carbon FRP laminates or wraps that should be used only for the structural strengthening. I have found at many places that is not required, but people are putting. Only weathering action is there. There is no structural crack, but people are putting that also. So if you want to enhance, say, flexure strength of the girder, shear strength of the girder, then let us put that one. Otherwise, it is no use. If structural requirement is not there and putting these things, then it is really harmful, you can say, because you are just covering the structure and you are not removing the actual cause. Actual cause of cracks, weathering action is due to rusting of reinforcement. So you have to treat that rusting of reinforcement first. 90% cases I told that is only weathering action, rusting of reinforcement only. The 10% only we required for the actual structural strength. So you have to judiciously use, not only the crack. Crack you have to see whether it is a flexure crack, shear crack, then only you go for that one.
Thank you, sir. I'm taking the last question. Mr. Sayyad asked, sir, you highlighted the failure of elastomeric bridge bearing where replacement is the ultimate solution. Could you please shed on some light on the approximate cost of replacement and any other recommended rehabilitation measures for such failures?
Yeah. Generally, this elastomeric bearings, we are thinking it will go for 15 to 20 years. But with proper maintenance, if your expansion joint is leaking from day one, you are not maintaining expansion joint, it will go in 7 to 10 years also. Because it depends how we are maintaining. Without maintenance, this structure, whatever we are designing, it will not go for 100 years. If we are maintaining properly, only these two things I am telling, drainage spot and expansion joint, then it will go for 75 years. In some cases, we have seen the bearings which is put at the time of just concreting the structure, then putting the girders, you can say, and that is working after 40 to 50 years in well condition because they are maintaining expansion and this is very, very small numbers. But that prove that if we are maintaining our expansion joint properly, this 15, 20 years is not sufficient. It will definitely go for 30 years also. So it depends actually how we are maintaining. If we are not maintaining, yes, you can expect in 7 to 10 years also, failure of bridge, these bearings.
Thank you, sir. Thank you. Dhawan, sir, you may please.
In your Sahu, you are
Sir,
a bridge engineer having really a good experience over 35 years. So, the important things that you are highlighted here are the proper design, proper construction, proper operation maintenance. So, the proper bridge inspection, then proper condition assessment, then we need to do non-destructive test evaluation, take core samples and the test to find out the present strength, and then proper remedial measures. And you have said the new codes SP18, SP34, SP40 for maintenance of highways. One should read, refer, and use them during planning, design, and construction of maintenance. And then the structural health monitoring, as you said, by putting sensors, depending on the conditions, is now very, very important. Database management system. And then finally, you said mission 2026 for proper and preventive maintenance. If we do all those things, then we can ensure that after the construction, the structure can be used for even 100 years. So these are the things which you have clearly highlighted and explained in a very, very simple way. And I'm sure the 250 persons who have attended your webinar will get benefit. Now, on my behalf and behalf of Institution of Structural Engineers, we thank you very much for sparing and sharing such a valuable experience. Thank you once again.
Thank you, Dr. Dhawan. I request please circulate all the requested members my presentation so that they can enjoy this one and implement in some structures.
Yes, sir. Sure, sir.
Okay, thank you so much. Thank you so much.
Once again, sir, you have invited me for sharing my knowledge. I am really very glad. And I always welcome whosoever is having some problem. He can contact with me by phone, by telephone, or by mobile, by mail, anything he can contact for any bridge engineering problem. Thank you, everyone.
Thank you, sir.
Thank you so much. Thank you. Thank you very much.